This is section 1.1 of AP Statistics. A categorical variable is a description of groups or things. A quantitative variable is a numerical variable, such as counts and percentages. A distribution is a listing showing all the possible values of data and how often they occur. A data table is just basically data organized into rows and columns. Frequency table is constructed by arranging data values with their corresponding frequencies. Relative frequency table is a chart that shows popularity based on the population sampled. There are two types of graphs, bar graphs and pie charts. Bar graphs are more preferable because they are easier to compare and easier to make. Marginal distributions are the data on the margins of a two-way table, which are the totals. A conditional distribution is used to examine a relationship between categorical variables. Segmented bar graph is a distribution of each value of one variable stacked on top of each other to form 100%. Association means that one variable helps predict the other variable.
The three graphs that you can use to display quantitative data are stem plots, dot plots, and histograms, and you can see on the side what they look like. So we can describe these types of graphs with SOCs: shape, outliers, center, and spread. So we basically know how to do this already, so I'm not going to go too much in depth, but shape, you're looking at where are the peaks, where's the main cluster of data. You're looking at, is it roughly symmetric or is it skewed? Are there distinct clusters or are there gaps? And gaps is really important. We did a recent FRQ in class where gaps, identifying that there was a gap between the two distributions, gave you a point, so don't forget about all this stuff. Outliers, you're looking at data that lies outside the overall pattern of the distribution, extreme values. And you want to make sure you use the word potential if you don't have the numerical evidence to back up that it is an actual outlier. Center, you're looking at midpoint, mean, or median. At this point in this section, we're not supposed to know mean or median, so we're really looking at midpoint. And with spread, you're looking at variability. How much does the data in that distribution vary? And again, at this point in the chapter or section, we don't know IQR or other ways to describe spread yet, so I just put range as an example. Speaking of examples, let's take a quick look at an example of comparing two distributions with the SOCs method. So I can't go through all of this for lack of time, but I'm just going to hit a few main points, which is that you should see that I am saying words like seem, potential, about, which are all vague words because I don't have the numerical evidence to back up most of the things, such as outliers. So I have to say potential outlier. And I'm saying it doesn't seem to have any outliers. So I have to be vague in order to get the points. Also, I'm comparing, I'm not just stating values, I'm saying more than or less than. So some tips to end this section. Make sure you're comparing distributions, don't just state values. Like I said in the example, say more or less than. Histograms, they are quantitative data, but bar graphs are categorical. And if you have two data sets of different sizes, use relative frequency histogram to compare them. And check out this calculator corner for how to draw a histogram on your calculator, TI-84. That's it for section 2. Bye guys.
We can describe quantitative data by looking at the center. The mean or average of the data is one form of center. X bar is equal to the sum of the observations over n observations. We can find the sum of the data and then divide by the number of observations, 5, to get a mean of 5.2. A population mean is represented by mu and is calculated the same way. One thing to keep in mind is that the mean is not a resistant measure of center. It is influenced by skewness and outliers. Another measure of center is the median. The median is resistant to skewness and outliers. We first have to arrange the data from least to greatest. The median splits the data into two halves. We see that 5 is the median. If we have an even number of observations, we take the average of the two numbers in the center. So in this case, our median would be 4.5. If the data's distribution is symmetrical, the mean and median will be the same. If the distribution is right skewed, the mean will be pulled towards the larger values, so the mean will be larger than the median. And if the data is left skewed, the mean will be less than the median since the mean is not resistant to skewness. We can also use spread to describe quantitative data. Three measures of spread are range, IQR, and standard deviation. Range is the value of the maximum observation minus the value of the minimum observation. The standard deviation is the average distance of each observation from the mean. Like the mean, the standard deviation is not resistant. Standard deviation can be found using this equation. We use the notation Sx when finding the standard deviation of a sample. However, we use this notation when we find the standard deviation of the population. The interquartile range is found by subtracting the value of the first quartile from the value of the third. The first step is to find the median. The median of the data to the left of the median is the first quartile, and the median of the data to the right of the median is the third quartile. 30 minus 10 gives us an IQR of 20. Like the median, the interquartile range is resistant to extreme observations. For any set of quantitative data, we can go to Stat, Edit, and enter our data in this list, and then we can go to Stat, over to Calc, and one variable statistics. We get the mean, standard deviation, and if we scroll down, we get the 5-number summary, which is the minimum and maximum values, and the first and third quartiles and the median. We can use the 1.5 times IQR rule to see if our data has any outliers. Our IQR is 20, times 1.5 is 30. The third quartile plus 30 is 60, and the first quartile minus 30 is negative 20. Since our data does not have any observations outside the range negative 20 to 60, it does not have any outliers. This is what a box plot would look like for this set of data. Our median is at 18, our first quartile is at 10, the third quartile is at 30, and the minimum is 2, and the maximum is 40, and we have no outliers. Outliers would be represented by an asterisk.